quality and integrity of nanometer size liposome during aerosolization. And I'm Saptarshi Chattopadhyay. Before I move to my topic, I would like to stress upon some of the terminologies over here. First is liposome. This is the basic particles which I'm atomizing. The rough estimate of this particle, the size of this particle, the outer diameter is of the order of 100 to 150 nanometers. And we are looking onto aerosolization technology. So basically these liposome particle in suspension is being atomized using some aerosolization technology into droplets. These are respirable droplets, airborne droplets, which are inhaled by human beings for drug delivery. We know that human airway is bifurcated and trifurcated into various structures, and at the end of which there are lobular structure called as alveoli. Now, there are certain advantage of depositing the drug in alveoli, basically because the number of physiological barrier which a drug experiences in other routes of drug delivery, for example, injection or ingestion, is less in case of the alveolar deposition. So when we are focusing on liposome for alveolar deposition, we are actually looking on some of the aerodynamic property. For example, the inertial impaction of these particles. Inertial impaction depends on inertial mass, so it depends on the density of the particle, how fast it can settle, whether it can settle on the upper respiratory region or it can penetrate inside the alveoli. The second is diffusion of the particle, which is driven by the diameter of this particle when they are airborne as well as when they're in suspension. And third one is of course drag force, because it is in air streamline, so it experiences a drag force which is dependent on the surface properties as well as the morphology of the particle. Now, what are the challenges in this kind of research? The challenges are following. First is an air-jet nebulization is associated. It's a sheer intensive aerosolization process. So this air-jet nebulization is associated with a disruptive effect, which means it can tear off this membranous labile molecule, and it can cause leakage or loss of encapsulated drug from the liposome interior to the exterior. Some of the modeling paper which had been published from our group shows that a particle size of 50 to 200 nanometer, I need to mention these are airborne particle size, are having more efficient delivery of the drugs. And third, aerodynamic distribution of particle size of 300 nanometer size liposome had been centered around 3 to 5 micrometer and polydispersed, which essentially says that the aerosol particle size is governed by droplets which are generated and not the particle. So here